Hey guys, today's video is all about Agentic RAG. We will understand what is Agentic RAG, the importance of Agentic RAG, and at the end of this video, we will also try to build a simple Agentic RAG workflow using CrewAI, LangChain, and Grok. So let's get started. So we all know that Retrieval-Augmented Generation (RAG) is the process of optimizing the output of large language models using an external knowledge base attached to a vector database. So that's how LLMs can easily retrieve the contextually relevant responses back to the user, right, in a RAG setup. So this is all okay until we have simple documents and use cases like creating a simple chatbot, Q&A chatbot and all that. But with the recent introduction of autonomous AI agents, the researchers thought, hey, why not integrate these AI agents in our RAG pipeline? Because these AI agents are able to plan, come up with logic, reasoning, and also they have this capability of calling any API or tools whenever there is a requirement. So this gave rise to the so-called agentic RAG, right? So the agentic RAG basically utilizes intelligent agents and advanced LLMs to streamline and enhance the retrieval and generation process, making it more efficient compared to your traditional RAG approach, right? So if you see in this diagram here, we are basically using agent. When a user query comes in, it goes through your traditional RAG type of setup, and if the answer or the response generation is all satisfied, it's all okay. It'll end according to you. But if you want, if the user query or the task is really complicated, that is where we can basically use the so-called agents. They have the capability of calling any tools, as you can see in the image, and they can take their autonomous actions, right? Hey, let's do this to solve this particular problem. So that's how the whole setup of agentic RAG basically works, right? So if you see the your traditional RAG approach, it's kind of simple. There is no use of any AI agents, right? Where your documents, the knowledge, the custom knowledge gets stored in a vector store or vector database, in the form of vector embeddings. And when any user query comes in, it goes through the vector database using vector search and to find the relevant chunk. And now that you have the context and prompt, it basically goes through the LLM to respond back to the user. But what if the user query or the task is really complicated, right? Uh, where you want to call different tools and do a lot more stuff. That is where the naive or the traditional RAG system approach fails, and that is where the agentic RAG basically helps you by integrating agents, and yeah, that's how basically the agentic RAG works. Um, Hey guys, so here is a simple tutorial of agentic RAG using CrewAI and LangChain. We're going to see how we can, basically integrate these AI agents in our RAG workflow to retrieve the most relevant information, right? Contextually relevant information. And what if the the information we are looking for, if it's not present in our custom data, then what we will do, we will call a tool and tell the tool, hey, go to the internet and try to find the relevant information and come back with a response. So that's what we're going to do now. So first things first, install whatever is required: CrewAI, LangChain community, sentence transformers, Grok, and then let's mention the Grok API key. Mention the LLM being used. That is what we are doing now. The model name is Llama 3 8B8192. And we are basically using this particular PDF. Attention is all you need. The publicly available PDF to as our custom data. Okay. So let's create a RAG tool variable to pass our PDF. Okay, that's what we are doing. We are building a RAG tool to pass our attention is all you need PDF that we used here. And then what we're doing is we are basically asking a simple question like, how did self-attention mechanism evolve in large language models? As you can see, it is going through the PDF and coming back with a response. Now let's use our Tavily as our tool. It's basically a search tool for large language models. So we are basically using that. That's why we are mentioning the Tavily API key. Uh, and this is basically a web search tool. So if we ask that, right, what is a self-attention mechanism in large language models, as you can see, it will come up with the responses with different references from the internet. Okay, so let's define a tool here. Okay, so it's a very simple thing like uh, for our question, right, for our any term that we are using, if it's present in our vector store, return the answer. And if it's not present in our vector store, the custom data, go through the web search and find the answer. Okay, so that's what we are defining as a tool. And then let's create agents to work with, right? So as I said, right, agentic RAG is all about using these autonomous intelligent AI agents. So we are creating a router agent and we are giving it a role, the goal and the backstory. And similarly, we are creating a retriever agent, again, role, goal and backstory, right? To have the context for these agents, and then grader agent, right? To basically grade, as you can see here, right? You are a grader assessing relevance of retrieved document to a user question, right? And then hallucination grader, basically, uh, you know, uh, we are giving it a reference saying, hey, you are a hallucination grader assessing whether an answer is grounded, how correct the answer is, contextually relevant the answer is, supported by a set of facts, right? And then answer grader, you are a grader assessing whether an answer is useful to resolve a question. So we are basically defining a bunch of creating a bunch of agents here. And then for all these agents, we are defining a task, their task. Okay, that's what we are doing, right? Router task, retriever task, grader task, hallucination task, and answer task. Now we created agents and we defined their task, and then let's define a flow for the use case, for our use case, right? We are basically defining a flow. And let's ask a query, right? This is our query. How does self-attention mechanism help large language models? So once you kick off the agent pipeline, right, the RAG agent pipeline, as you can see, uh, it goes through step, right? Agent, working agent router, and it says that, hey, the answer is actually present in the vector store. No need to go to the internet. Let me answer back, right? See, the final answer is present in the vector store, right? Next, the working agent is retriever. Um, as it says, like based on the response from the router task, extract information for the question, how does self-attention mechanism help large language models? With the help of a retrieve tool, use the web search tool to retrieve information from the web in case the router task output is web search. But our output is actually vector search, vector store. So that means our answer response is actually present in our vector store. So it says that the output is actually vector store. Let's enter and see the next thing, right? Entering new CrewAI agent, Crew agent executed chain. Thought. I now have the context and the task to extract information for the question, how does self-attention mechanism help large language models using the vector store? So as you can see the final answer here. So this is basically present in our data, in our the self attention. Attention is all you need. That PDF we attached as a custom data, custom knowledge source. That is where it says that hey, the answer is already present in our vector store, and this is the answer. So it basically finishes the chain and it gives us the answer, right? And slowly different agents come and then they try to analyze whether how grounded the answer is, how what is the hallucination grader, as you can see here, right? So it says like based on the response from the grader task for the question, how does self-attention mechanism help large language models? Evaluate whether the answer is grounded in evaluate whether the answer is grounded in supported by the set of facts. As you can see, thought I now can give the great answer. The final answer is yes. So step by step it goes, right? As you can see, hallucination grader task output. Yes, the answer is grounded. It is contextually relevant, and then comes the working agent with all the answer back, right? And once you run, hey, print the final answer. As you can see, it basically prints the final answer back to us for our question, how does self-attention mechanism help large language models? The self-attention mechanism in large language model helps by allowing the model to focus on specific parts of the input sequence and weigh their importance. So that is how different AI intelligent AI agents come together. We can actually form a chain. That's why we are using LangChain here to basically iterate through these different agents and then come up with a final contextually relevant answer. So this is about that's how you can basically use call different tools, all right, and come up with a contextually relevant answer or response back to the user. So that's about the agentic RAG workflow. I'm going to share the link to the code, the notebook code in the description so that you can go through and then try to understand how you can use different tools and these AI agents in your RAG workflow and come up with a proper contextually relevant answer. Thanks.